From the moment we first stood upright and lifted our gaze from the earth beneath our feet, humanity has always looked up. In the velvet darkness of the prehistoric night, free from the glare of modern cities, the sky was not a distant, abstract concept. It was a living, breathing entity, a ceiling of impossible brilliance. This profound connection to the cosmos is woven into the very fabric of our species. It is a primal instinct, a deep-seated curiosity that transcends culture and time. The stars were our first campfire stories, our first calendar, our first map. For ancient civilizations, the predictable march of the constellations marked the changing of seasons, guiding the planting of crops and the timing of harvests. For Polynesian navigators, the star paths were luminous highways across the vast, featureless Pacific, a celestial GPS that guided them to new lands. The sky was a source of order in a chaotic world, a constant in an existence defined by change. We gazed at the pinpricks of light in the night sky and we wondered, what were they? Divine beings? Campfires of the gods? Holes in a great dark dome that separated us from a realm of pure light? With no tools but our own two eyes, we saw planets as wandering stars, their strange, looping paths a puzzle that confounded the greatest minds for centuries. We saw the Milky Way, not as a galaxy of 100 billion suns but as a celestial river, a backbone of night. We saw comets and meteors as terrifying omens or divine messengers. To make sense of the celestial chaos, we told stories about them. We connected the dots into constellations, creating heroes and monsters from the celestial tapestry. We projected our hopes, our fears, and our values onto the heavens, populating the darkness with figures like Orion the Hunter, forever chasing the seven sister stars of the Pleiades. These myths were more than simple tales. They were complex mnemonic devices, encoding vital knowledge about navigation, seasons, and cultural identity, passed down through generations under a shared canopy of stars. For millennia, our eyes were our only tools, and yet with them, we achieved wonders. Astronomers in Babylon, Egypt, Greece, and China meticulously charted the heavens, creating star catalogs and predicting eclipses with astonishing accuracy. They developed sophisticated mathematical models like Ptolemy's geocentric system which, while ultimately incorrect, was a triumph of scientific reasoning, perfectly explaining the observational data available at the time. But the human eye, for all its power to inspire, has its limits. It can only see so far, and it can only perceive a tiny fraction of the light that the universe truly emits. A fundamental barrier stood between us and the true nature of the cosmos. Then, in the early 17th century, a revolution. Then came the telescope, a simple tube with lenses that brought the heavens closer. While not its inventor, it was Galileo Galilei who first systematically turned this new device to the sky, and in doing so, shattered the old world forever. He saw that the moon was not a perfect, ethereal sphere, but a rocky, cratered world like our own. He saw that the Milky Way was composed of countless individual stars. And most profoundly, Galileo showed us the moons of Jupiter and the phases of Venus. The 4 Medicean stars orbiting Jupiter were undeniable proof that not everything in the cosmos revolved around the Earth. The phases of Venus demonstrated that it must orbit the Sun, not the Earth. With these observations, the walls of the old universe came crashing down. We were not the center of all things. We were residents of a planet, one among several, orbiting a star, one among countless others. This revelation was a profound demotion, but also a glorious liberation, forever changing our place in the universe. It was the dawn of modern astronomy, the beginning of a new quest, not just to map the heavens, but to understand them. In the centuries that followed, we kept building bigger and better eyes. From Isaac Newton's revolutionary reflecting telescopes to the colossal observatories perched atop remote mountains, our view grew sharper, deeper, and wider. We discovered new planets in our own solar system, and then in the 20th century, Edwin Hubble proved that the faint, spiral nebulae were in fact entire galaxies, island universes like our own Milky Way, scattered across unimaginable distances. We learned the universe was expanding, but even these mighty ground-based eyes are hampered, looking up through a turbulent, shimmering atmosphere that blurs and distorts starlight. To take the next great leap, we had to leave the ground behind. The age of space telescopes began, culminating in the magnificent Hubble Space Telescope. For over 3 decades, Hubble has been our tireless eye in orbit, revealing the beauty and complexity of the cosmos in unprecedented detail. Yet for all its triumphs, Hubble raised as many questions as it answered. It showed us galaxies in their adolescence, but it couldn't see their infancy. It showed us the dusty clouds where stars are born, but it couldn't peer deep inside. It could study planets, but it couldn't taste their air. To answer these deeper questions, we needed a new kind of eye, an eye that could see a different kind of light, an eye that could look further back in time than ever before. Today, we have that new eye, the most powerful one ever built. It is the result of decades of planning, innovation, and international collaboration between NASA, the European Space Agency, and the Canadian Space Agency. It is a testament to human ambition on a cosmic scale. It is called the James Webb Space Telescope. This isn't just another telescope, it's a time machine. This is not science fiction, it is a fundamental property of light. Because light travels at a finite speed, the farther we look into space, the further back we look in time. The light from the sun takes 8 minutes to reach us. We see our own star as it was 8 minutes in the past. The light from our nearest neighboring galaxy, Andromeda, takes 2.5 million years. Webb is designed to capture light that has been traveling for over 13.5 billion years. It will allow us to witness the cosmic dawn, the moment the very first stars ignited and pierced the darkness of the early universe. To do this, Webb must overcome a cosmic challenge, the expansion of the universe itself. As light travels across these vast stretches of expanding space, its wavelength gets stretched, shifting it from visible and ultraviolet light into the infrared spectrum. Webb is engineered to see this ancient stretched light. It's an infrared detective. Seeing in infrared is like having a superpower. This invisible light passes right through the immense clouds of cosmic gas and dust that block the view of telescopes like Hubble. With its infrared vision, Webb can peer into the heart of stellar nurseries, witnessing the birth of stars and their planetary systems in breathtaking detail. Infrared is also the light of cool objects. Young planets, faint brown dwarfs, and even the complex organic molecules that are the precursors to life all glow with the faint warmth of infrared radiation. Webb can detect these faint heat signatures, opening a new window onto the cradles of life. It can even analyze the atmospheres of planets orbiting other stars, searching for the chemical fingerprints of water, methane, and carbon dioxide, the very gases that signify a potentially habitable world. To achieve this, Webb is an unprecedented marvel of engineering. Its primary mirror is a staggering 6.5 meters across, composed of 18 ultra-lightweight beryllium segments, each coated in a microscopically thin layer of pure gold, which is exceptionally reflective of infrared light. This giant mirror had to be folded like origami to fit inside its rocket fairing. To detect the faint infrared signals from the edge of time, the telescope itself must be incredibly cold, colder than any freezer on Earth, down to minus 233 degrees Celsius. To achieve this, Webb is protected by a 5-layered sun shield the size of a tennis court. This shield creates a 1,000,000-to-1 difference in temperature between its hot, sun-facing side and its frigid telescope side. And to keep the sun, Earth, and Moon constantly behind it, Webb doesn't orbit the Earth like Hubble. Floating 1,000,000 miles from Earth, it orbits the Sun at a special gravitational balance point known as L2. It is our golden eye on the cosmos, a cold, lonely sentinel on the frontier of human knowledge. The journey to this point was fraught with peril. After decades of development, the telescope was launched on Christmas Day, 2021. But the launch was just the beginning. What followed was the most complex, nail-biting deployment sequence ever attempted. Over 300 single-point failures, any one of which could have doomed the $10 billion mission. For 30 days the world watched as Webb flawlessly executed its robotic ballet, unfurling its sun shield, deploying its secondary mirror, and unfolding its golden primary mirror wings. It was a triumph of human ingenuity. And now, the rewards are flooding in. Its mission is profound, yet simple to state, to see the very first things. And in doing so, it is rewriting the astronomy textbooks. It has given us staggering views of the cosmic cliffs, a landscape of starbirth previously hidden behind dust. It has captured galaxies colliding in a cosmic dance, and the dying embers of a star in the Southern Ring Nebula. It has delivered the first definitive evidence of carbon dioxide in an exoplanet's atmosphere, and has peered back to see galaxies shining just 300 million years after the Big Bang, earlier than we ever thought possible. Each new image, each new data point, is a postcard from a previously unseen universe. Webb is not just fulfilling its promise, it is exceeding it, opening a new golden age of astronomy. It is the legacy of every human who has ever looked up in wonder, the culmination of a journey that began with a naked eye and a curious heart. It is our shared quest to answer the most fundamental questions: where did we come from? And are we alone? The journey has just begun.